My name's Mark. People call me Pipes. I work for Insomnia Security over in New Zealand. If you don't know who we are, look us up, insomniasec.com. And this is kind of a real quick whirlwind tour on certificate transparency. So the way I ended up here is I was at CrikeyCon last year, and Fraser gave an excellent talk called Controlling the Dumpster Fire, a look into CAs. It's on YouTube, it's really great. He effectively covered like what's the deal with CAs and what are the technologies that we're currently going in on them to sort of help make them more trustworthy and whether or not we can bring back trust into the root of certificates. And he had one little touch on near the end of his talk around certificate transparency. Now, I had already sort of seen some stuff around CT, but I decided that it was probably time that I went and had a look at them. And this is kind of the result of that. It's not as in-depth as I would like, just due to some family stuff late last year, but hopefully you'll walk away at the end of the day with a bit more of an understanding about like what is certificate transparency, what does it mean, how can you use it. So certificate authorities are important to understand before we go into it. The problem is certificate authorities are really boring, right? Like if you read the Wikipedia article, you'll be asleep by about the third paragraph. They say stuff like, you know, electronic documents and signing and PKI and everything else. So I asked around the office, and my good co-worker Middlestorm said, well, certificate authorities are like toast. That's great, man. What do you mean? He goes, no, I got nothing. So certificate authorities are like toast. But as a quick whirlwind for those who aren't familiar with certificate authorities, effectively, if you have a browser, which you'll see on the screen is presented as a blue box somewhere in there, if you have a browser visits a website, it gets handed a certificate. And that certificate is effectively the website presenting its identity to the browser. The problem is that how does the browser know that that certificate is the right certificate, that it's trusted, that it's been presented in a correct format? And the answer is you have your certificate signed by a certificate authority, right? And so effectively what it is, you effectively generate a certificate signing request, which is a base certificate. You submit it to the certificate authority, say, hey bro, can you please sign this for me? They say, yep, give us some money, we'll sign it for you. They sign it for you, they hand it back, you put it on your web server, and then when people visit, the browser goes, actually, is this signed by a known certificate authority that I trust, right? Is effectively the base part of it. There are multiple authorities, there are over 200 if you have a look at a modern operating system. To get your CA signed generally costs money, right? That's changed a lot in the last 2 to 3 years with Let's Encrypt, which is a more community-driven project and one out of social good, with the idea of we want to take the power away from these fat cats that are taking all the money just to have trust on the internet. And you can have different levels of trust, right? So how your certificate is signed can have different levels of trust, and that's usually determined again by how much money you're willing to pay a various certificate authority. And there's a bunch of additional functionality that certificate authorities provide, such as revocation, right? So if the certificate's compromised and gets, I guess, taken offline or end of lifed before it's due to be end of lifed, then there's a check process and a protocol that runs in the background that says, yo, what's up? But a lot of the stuff that certificate authorities deal with aren't really important for us today. The main problem we have is that in any modern operating system, there are, as I say, hundreds of certificate authorities, which means any certificate that's been issued via those certificate authorities are trusted in a sense within the operating system. And we're mostly talking about within the browser here. And there's a lot that just don't make sense at first glance. Like, I'm not entirely sure why my work laptop trusts Hong Kong Post. And it turned out that that authority exists because Hong Kong had the idea that they were going to do their own CA infrastructure related to identities for their citizens, right? Similar to Estonia, with the way that Estonia has a digital identity for every citizen. Anyway, so they're complex, there's many of them. How do we know that we trust them? And everyone sat around for pretty much the last 20 years until a few years ago, living in a certificate utopia, right? Like there was the Enterprise flying through the sky, the Federation existed, Disneyland was awesome. And we were like, you know, this is trustworthy, right? This is what it goes for. The reality in this utopia is that we had significant trust issues with certificate authorities, right? And this is because of a number of reasons, like things like they're across multiple jurisdictions, right? What goes for trust and understanding in China does not necessarily relate to what goes in trust and understanding in the United States, and neither of those go with what goes on in Europe a lot of the time, right? So our standards that we hold them to sort of vary greatly, and some of them have really poor standards. Some of them are, it is the government-run certificate authority, you will trust it. And there's no auditing of actual value. There's no auditability in any of this, right? And this is one of the, if you talk to people who spend a lot of time in the certificate space, this is the #1 issue that's going around at the moment, which is, well, in order to become a certificate authority, you have to go through the engineering work groups, you have to show that you've done a lot of work and that you're getting regular audits and this, that, and the other. And if you actually go request any of that information, they go, well, it's NDA, we're a corporate entity, you're a corporate entity, we're not going to share that information with you. So getting some transparency on what's going on is not that easy. When I initially started looking at this, I was aware of 2 or 3 major certificate authority incidents. It turns out there has been dozens over the last 10 years, way more than I could have ever anticipated, to be honest. A really good starting list on the more significant incidents has been put into this Git repo, which is linked on the slide. And if you haven't read it, I highly recommend you go and read it, because it gives you an idea of just how blind our trust has been over the last sort of 20 years with this infrastructure, and given its criticality is kind of a little bit concerning. So what are some of the issues that we're seeing with CAs, right? What's some of the trust breaches? Well, we're seeing issues for certificates to just straight up non-bad actors. Like, they know this person is bad. Like, well, we know this person is bad, but there's no actual checking on going on who's requesting the certificates. Lack of request validation, so me just creating CSRs for various other organizations, putting them through reseller accounts with less verification that would probably go through on them. Issuance of wildcard certificates, so if you have a CA that issues a wildcard certificate, that certificate can present itself as trustworthy for any site of their choosing. So that can lead to man in the middle, and is quite often what interception appliances rely on. Issuing a test certificates. So one of the examples we'll look at in a minute is, situations where test.sh, like some shell scripts, actually generating certificates that could be valid in the wild for millions of browsers. And a compromise of the CA itself, right? We like to think that certificate authority means they are authoritative, therefore they are secure, and that is not necessarily the case. So some examples, malware issuance. So in 2011, Komodo got caught out issuing certs for malware. So it turned out the Iranians had owned one of their reseller accounts and were just logging into a vendor interface and being like, hey, can I have a certificate for login.yahoo.com? Okay, thanks. And they're like, yeah, sure, no worries. And there was pretty much a target list that you kind of want people not to be able to intercept at that time on the internet, right? DigiNotar, everyone's probably heard of DigiNotar if you've followed any major incident and breaches in the last 10 years. They had this wonderful thing where they got caught out issuing wildcard certificates for google.com, so star.google.com, which could be used for a whole bunch of stuff on that. It turned out their hardware security module, so the bit that has all the cryptographic keys that does the signing, was just sitting around on the LAN. It was unpatched. The Windows servers were compromised for months that they could verify in the forensics that they did, but they assume years because they had suspicions that the actors had been in there for years. As a net result of this compromise, basically DigiNotar no longer exists, right? They were never going to get their trust back as a CA. All the browsers blacklisted and said any certificate that came through DigiNotar, we don't want to know about. A great trust chain example was actually Symantec. They got busted issuing intermediate certificate authority certs to Blue Coat. So the idea is that when you're an intermediate, you can sign on behalf of the CA itself. And they gave it to Blue Coat, which is notorious and been caught out a number of times selling appliances to repressive regimes to man in the middle all internet traffic for entire countries. So an intermediate certificate being issued there would actually be quite useful for them. When they were caught on it, they were like, no, we were trying to find man-in-the-middle attempts in Saudi Arabia. And when asked how, they kind of just went quiet and disappeared into the night. Backdating, so we were in the middle of a SHA-1 depreciation for signing of certificates recently, and WoSign got caught out basically issuing certificates with identical serial numbers and X509 extensions, and the only exception was the not before field. So basically they were issuing certificates that would be valid with SHA-1 signing for a longer period than what would have been acceptable under the deadlines for the SHA-1 depreciation period. And the most recent example, which has been fascinating to follow, if you have a chance, go dig up the mailing list archives that are on groups.google.com around this one, but effectively, Symantec got caught, I think, issuing about initially 13 or 15 certificates for google.com. And Google were like, nah, that's not on. Can we have a bit more of an audit, please? And they went, sure. Oh, actually, it was 30,000. And this was developers and test scripts and like continuous integration systems doing testing against production CA infrastructure, right? So, and the interesting thing about this one is it's my understanding this was actually caught out through certificate transparency. And yeah, so where we end up is basically in a position where we know the CAs are fat cats. You trust them as much as you trust Tony Soprano, right? They love to shake your hand, take your money, but they'll stab you in the back, and they do all sorts of crazy stuff in the background, and they have goons running around doing stuff. So Google got pretty grumpy about this, and in 2013 proposed a new RFC. It was 6962, the idea of certificate transparency. And in a nutshell, it basically says we want a way to be able to have a public auditable log of any certificate that's being signed and issued out of a certificate authority. The interesting point here is actually highlighted in bold, which people are only just sort of catching on to now. And the intent is that clients, i.e. your browser, Chrome, will be in a position where they can opt not to trust your certificate if it hasn't been put out into the log, right? And we're actually at this point now. If you look at certificate transparency data volume, it has exponentially grown over the last several sort of 6 to 12 months, and that's because Chrome, I think in July, are actually going to start bringing this in where they're like, if you're not logging, we're not going to trust you. So the too long didn't read of the RFC is effectively, it sets down a process on how we should build these effectively immutable logs. So that means they can't be tampered with. They've like sort of got their own cryptographic integrity checks in them. You should have to log to one or more instances, so multiple instances. The log should be public, which as a result means the log should be auditable, which is a key point. And the rest of it kind of just gives specifications on how logs should be stored, how they should be accessed, how they should be duplicated for redundancy, as well as other stuff like if you're lagging behind by more than 24 hours, you should drop yourself off and lock that log and bring in a new log and stuff like that. So it's kind of just specification around that. It's really well thought out and written, but at the same time you can tell that it's been kind of rushed, and there's a new revision of the RFC. There's effectively Certificate Transparency 2 that's currently in draft and coming out shortly, that basically addresses the limitations with the current RFC, and most of those limitations are, I don't think they expected the volume and exponential growth that they got with this solution. It was very experimental at the time, and it turned out to be super useful. So my question to myself after watching the talk last year and after having a bit of think about it was, if there's a public log of every certificate that's been issued via a CA that is logging to CT logs, can I go query it? And the answer was yes. And there's several log interfaces that exist that you can use to do this, right? There's the Google Certificate Transparency Report. There's Facebook Developer Tools. They have a really good interface. And there's cert.sh. There are other ones as well, but they were the ones that when I first started this in sort of February, sort of March last year. So for example, with Facebook, if you're a Facebook user, you can just go to the developers.facebook.com. There's two interfaces. There's an API that you can sort of do search queries off. You can also do subscriptions to say, hey, if there's a new log entry that matches this domain that I'm interested in, it will actually send you an email or a webhook notification. Or you can just punch it in on the web interface, subscribe to your email, and away you go. It's all good. The problem is I like to do things at scale, like usually country scale for New Zealand, because I care about New Zealand. And I hit a number of issues with these solutions. They're slow and buggy. And even the Facebook one can be kind of weird on how it returns the data. And we're dealing with big data, and I don't know exactly how much resource and engineering they've put into these solutions. It's still been treated experimental until very recently. Limited coverage, so cert.sh, for example, I'm pretty sure there was instances where they were only reading probably 2 or 3 logs, and there's 14 logs in total approximately at the moment. So coverage was a bit of an issue. Right side search limitations, so sure, I could look up anything to do with insomniasec.com, for example, but if I wanted to find anything with insomnia on the sort of right-hand side, it was a bit of an issue. I did learn just last week that cert.sh, beyond the web interface, you can actually just point a Postgres client to it and do straight-up raw SQL queries on their data set, which includes right-side search. So that wasn't, I don't even think that really was around when I was doing this. Still buggy, like they're all buggy, and they all have API rate limiting. They do not like you throwing very, very, very large domain lists at them. So I decided the low-hanging kiwi fruit approach, fuck it, we'll just take the lot. So for those of you unaware, low-hanging kiwifruit is a system that Metalstorm built. We operate internally at Insomnia that basically allows us to scan .nz as a whole, like New Zealand Internet as a whole, and keep a massive database of records on services and ports and domains and stuff like that. So I thought what I'll do is I'll write some Python to download some logs. I'll parse those logs with a bit of Python, and I'll match based on a really basic filter. I want anything with .nz in the name, and then I'll save the certificate into a data set that I can play with later. Oh, and I'll profit, right, yeah. So my initial job was like, I went to Hetzner online, I grabbed one of their auction servers. It was like 32 gig, 2 terabytes of disk, 8 cores. I downloaded a series of logs, which took a while. I used all of the process procs to filter through .nz with a bunch of hacked up proof of concept code in Python. And it took 7 days to execute across basically a log. The logs themselves are Merkle hash trees that are compressed in zip, right? So the final data set that I was playing with at the time was around 900 gigs compressed, sorry, 900 gigs uncompressed. And it turns out there's actually a whole bunch of data. And if you've ever actually tried to parse certificates, right, X509 and ASM1 is a nightmare. Like if you do it at small scale, and when you go big scale, you find super weird and interesting things. And because it's an immutable log, any certificate that was misissued or issued with invalid fields is in the log, right? So OpenSSL, for example, did not handle this very well. Like I have many crashes out of OpenSSL. So yeah, and it turned out like if I wanted to take this to more scale, if I wanted to go across all the logs, like disk is cheap, RAM is cheap in the cloud, but CPU isn't. CPU starts getting expensive. And when you're doing zip operations, CPU is an intensive part of that, like it's CPU intensive work. But I ended up with this data set. I don't know how well it would show up on the slides there, but effectively it was a massive sort of tree of flat files. It had an index sort of CSV that said if you spot this name, it's in this hash. And then you can basically just cat the certificate out into OpenSSL and go through and work through it. And so most of my initial analysis on all of the data was basically set an awk over a file system, which wasn't too successful. So I decided to come back for round 2. And around the time that I was sort of throwing my hands and flipping the table and trying to figure out how to make multiprocessing in Python be more efficient, Ryan Sears drops this platform called CertStream. Right? And CertStream is effectively a real-time consumable API of all new log entries. So that's cool when he has clients for Python and Go. But he also dropped an interesting open source project called Axeman, right? And Axeman is effectively a usable version of my Python download code. And so what it will do is it will go through, it'll download using Python 3 async IO, it will download the zip files from the logs and actually parse them out and save them into a more usable CSV format and stuff like that. So I was like, all right, I'm down with the cloudy. I can get cloudy with it. I'm going to take all of the certificates, I'm going to shove them into Google Storage, I'm going to shove them into BigQuery, then I'll just query the BigQuery and profit, right? And the answer is yes, you can. So the process worked really well. And after I went through this and went through all the dramas of figuring it out, Ryan actually posted a blog post of, I think it's called How to Process 250 million plus sets like a boss. And he took the exact same approach. And he had a data set that already existed that he's willing to share with anyone. So I'm like, but anyway, so I end up effectively with a set of CSV files or JSON documents, depending on how you want to export them, that effectively has, here's the alternative subject name. So here's all the domain names or host names that the certificate's associated with, and we can work through with that. I wanted to have more time to analyze the data, and I didn't. So if you hit the QR code, you'll get a 10 gig tar BZ2 of Australian certificates up until last Wednesday. If you want to have a play with that, they're straight up CSV files. They're about 900 megs of CSV file, and I hope you're really good at awk. There's an interesting caveat to this, is I've been using CertStream for a bunch of the other stuff that we're going to talk about in just a minute. It disappeared on me when I was tidying up some slides last week, and I was really curious as to why. So I went to his tweeters, and he got a $1,000 traffic bill after migrating to Google Compute and just turned it off. Right, so there is always a lesson here on using a free service. You get what you pay for. I really hope he starts a Patreon or something and just lets us like throw money at him, because everyone's using CertStream at the moment. But it came back online just before the talk, so that's all good if you want to go through with it. All right, so what is all this good for, right? I'm on the red team for the most part. So for me, all I actually wanted to know was being able to find host names associated with targets, right? Having, for example, a massive data set where I can say, give me anything that's associated with Insomnia and NZ from a host name point of view is super useful and goes a long way. It's really good for, if you've ever been on a red team, you've had, say, you've fished some credentials, you've got some credentials, that's great. You've got RDS endpoint or remote access endpoint, and you know what it is, and it's expecting the format domain name / username, right? If you don't know what the domain name is and that hasn't leaked, it can be a really frustrating place to be. Thankfully, we've already had a couple of instances where they've issued certificates for, say, insomnia.co.nz, insomnia.lan, and insomnia.lan within the alternative subject name. So they're associating the certificates with both their internal and external DNS horizons. Reviewing data for a geographic region, IEAU, right? Like, it'd be really interesting to see what are the SHA algorithms in use on signing and pulling out some stats around all of that sort of stuff. Understanding extensions and use within certificates. So one of the things I've already found looking through the data is, especially when it comes to looking at wireless networks and how certificates being issued across wireless networks and stuff, is there are dozens of X509 extensions I didn't know existed, let alone I knew they were in use. And they're in use by appliances and various other useful things. So there's already one appliance, for example, that I know an X509 extension that if you query across the data set, you'll find their endpoints for their customers everywhere. So that's pretty useful. And I also think it will actually eventually make a pretty decent assistant in generating a corpus for fuzzing, right? Anyone who's ever fuzzed SSL knows, like, the hardest thing is actually figuring out a code branch that hasn't been fuzzed 5,000 times before. And we saw that with Heartbleed, right? Like, we saw that when they came out with Heartbleed. It was just hitting a strange code path that no one else had hit before. It was super obvious, but no one had actually taken that time to sort of fuzz it and go through it. So for the blue team visibility, Facebook have a really great post where they point out that their security team got alerts that someone was on the fb.com domain, which is their corporate domain, issuing valid certificates for something in there. And they were sitting there going, but not through our CA and our process, and our security team doesn't know anything about it. And they got a heads up on that through CT logs. It's really good for determining if phishing sites are incoming for targets. So any decent fishers nowadays are generally spinning up domains that sort of match with keywords. They all have certificates, so there's a bunch of hosting providers and cPanel solutions now that will automatically issue a Let's Encrypt certificate for every domain that's been added to the shared hosting box or whatever, or via the cPanel. But also understanding how certificates are being used within malware. I'm pretty sure that there's a couple of blue teams out there getting, I guess, better understanding of malware signing and stuff off domains that's coming through that as well. So because I'm in a big sort of thing at the moment where people keep saying, look, the red team keeps winning, you guys keep kicking everyone's ass, I decided that for any research that I do over the sort of next couple of years, I'm going to produce the blue team solution with it. So I took the time to build a blue team example that effectively says, all right, let's tap into the cert stream, let's monitor it, and let's see if there's any domain that sort of matches out with the keyword that I'm interested in. Can we do some recon, generate an alert, go through it? It kind of looks like this on my Slack bot for PayPal, for example, but I've been looking at PayPal, Apple ID, stuff like that. This was, I don't know, a couple of 100 lines of Python for the initial proof of concept. Probably the current version, which does a few more smarts, is probably somewhere around 400 or 500 lines of Python, right? There's nothing major to it. So you can get a heads up on what's going on out there pretty easy. Bonus, you can steal the phishing kits because you hit them so fast they haven't deployed yet. So one of the things that I found is that they would set up the site through compromised cPanels. They would upload their zip file, and before they unpacked it and set up the index.php to redirect and everything else, there'd be a zip file there. And I was seeing this in the screenshots for everything I was taking, and by the time I'd go back and revisit it, the zip file would have been deleted or they've configured the site correctly. So I just automated that with a little bit of Python, and you can steal a lot of fun phishing kits out of that. Fun fact, for most of them, pretty much 90% of them are backdoored, and it's a great game to go through figuring out how did the phish kit author backdoor them to send them the credentials as well. So getting started. So as I mentioned, like I did the blue team example, it was really straightforward. If you have a look at Bounty Monitor, which is around bug bounty sort of monitoring, it's a really great basic example. It's basically taps into SetStream, sets up a SQLite database, goes ahead and figures out, have I seen the certificate before, yes or no? Have I seen it recently? Do I need to recheck it? Should I look at the site or not? Should I log it? There's just dozens of projects if you go looking for SetStream on GitHub code search. So to conclude, so that we can get out of here and go to the pub before Glenn and that kill me, yeah, so CAs can't be trusted, we know this. We've got dozens of incidents that show they can't be trusted, and certificate transparency really has opened that up to be publicly audible. It is freely accessible. Like if you've got enough time and a little bit of patience and some Python, you can go download them all. You need a bit of disk and a bit of bandwidth. The AU data set that I put on the slide earlier, that was generated from 1.57 terabytes of data, something like 800 million rows. And it took 170 seconds on Google BigQuery, so that's all good. And it's also possible to incrementally monitor the log with free and open source tools, right? Like, I think SetStream needs to either formalize as a project a little bit, or maybe a bit more of a effort around how we can tap into streamable APIs to do with the set logs. Be great if Facebook opened that up a little bit more on their side or something. I don't know. Like there just has to be something a little bit more redundancy and reliability there than just Ryan. As much as I really appreciate Ryan's effort, it's pretty awesome. And there's a bunch of awesome starter projects to explore, and there's a bunch of ideas to explore, right? Like the more you go looking at certificates, the more it'll make your head hurt, like frankly, because as mentioned, there are just dozens of extensions, and people use certificates for things that I'd never actually considered. So that's well worth checking out there as well. And that's it with 13 seconds to spare.